Welcome back. Last video we talked about discrete random variables and how to find their probabilities. Today we're going to talk about continuous random variables and their probabilities. So a continuous random variable contains endpoints and everything inside the endpoint. There's no breaks, there's no jumps. It's all the values within an interval. So some examples of that might be temperature or length or weight. The temperature doesn't just go automatically from 90 degrees to 100 degrees. It includes every value in between also. It slowly rises. Think about a thermometer with the mercury, and the mercury is rising slowly up to a possible temperature. Just like discrete variables, continuous variables also have a mean and standard deviation. However, sometimes it's more difficult to calculate those because it'll be something like a normal curve. So usually those will be provided for you. Unless it's a shape like a triangle or a rectangle that has a clear center, you will be given the mean and standard deviation of a continuous random variable. So the way that you find the probability of a continuous random variable is that you find the area under the curve. So the area under the curve will give you the probability that whatever outcome you desire will happen. So if you find the area under a rectangle, for example, just like we did in chapter 2, you could have x values here, and then this would be p of x. That would be a uniform distribution. You could find the shaded area, and the probability from A to B would be the shaded area. A lot of continuous random variables follow a normal distribution, which is even easier to calculate because we've been calculating normal distribution curves since the beginning of the year. Here are some reminders about normal distributions that you need to know. You'll have a normal curve with the mean in the center, and then you go out by standard deviations. If you want to find the probability that x is less than or equal to some number, then you'll shade to the left or to the right based on the inequality. And then to find that, you would do normal CDF, lower, upper, mean, and standard deviation. If it was a greater than or equal to, you would shade to the right, and you can also do in between. It doesn't matter if you have x is less than or equal to a, or if you have x is less than a. That will give you the same probability, because with continuous random variables, you just want the area. You don't care about the endpoint itself. The line you're drawing has no area. So that's just a boundary point, and so these are going to give you the same probability. For discrete, it matters, but for continuous variables, the less than or equal to doesn't matter. Whenever you're doing normal calculations, don't forget to state, plan, do, conclude. And for these problems, state the given information. State the mean, state the standard deviation, write the probability statement. Plan, draw the curve. Do, write out the actual normal CDF. And then conclude, you'll have a sentence. So like the probability that blah, blah, blah is. So write out a sentence. So for normal continuous variables, that's what you do. Let's take a look at an example. The weights of 3-year-old females closely follow a normal distribution with a mean of 30.7 and a standard deviation of 3.6. We're going to randomly choose one 3-year-old female and call her weight X. So we want to find the probability that a randomly selected 3-year-old weighs at least 3 pounds, or 30 pounds. So probability that X is greater than or equal to 30. We know that the mean is 30.7 and the standard deviation is 3.6. That's the state part of our problem. plan, we're going to draw a curve to show the shading. We're going to put 30.7 in the middle, 30 is right here, and we're going to shade to the right. So normal CDF from 30 to very large, 30.7, 3.6. When you type that into the calculator, you'll get 0.5771. So the probability of randomly selecting a 3-year-old female that weighs greater than or equal to 30 pounds is 0.5771. So part B is asking a similar question. Find the probability that a randomly selected 3-year-old weighs between 25 and 35 pounds. So they're wondering the probability that a female weighs between 25 and 35 pounds. And remember, our mean is 30.7, standard deviation is 3.6. So my curve is going to have a 25 and a 35, and I'm shading in between. So we'll do normal CDF from 25 to 35, and the mean is 30.7, standard deviation is 3.6. And when you type that in, you get 0.8272. So the probability of selecting a 3-year-old that weighs between 25 and 35 pounds is 0.8272. Part C, we're going to work backwards. They give us the probability right here. So they give us the area, and we're going to work backwards to get the value on the curve. So we still know that the mean is 30.7 and the standard deviation is 3.6. They give us that the probability of x less than k is 80%. So here's k, and the area below k is 80%. And so if you remember from previous chapters, if we're given the area and we want to find the value, then we're going to use inverse normal. So inverse normal, the area is 0.8, and the mean is 30.7, standard deviation is 3.6. When you type that in, you get 33.73. So that represents the weight that has 80% below it. So 80% of 3-year-old females, weigh less than 33.73 pounds. So now we've talked about discrete variables and continuous variables. Our next lesson is going to be about continuous variables and discrete variables where we're changing the units. And since the only feedback I got from my videos is that I had a cringy sign-off, I am now taking suggestions for a new sign-off. Please make sure you're practicing typing all of these things into the calculator as you're filling out the notes so that you're competent using a calculator when it comes to quiz and test time. Be prepared for a pop quiz tomorrow.